Hey all, welcome to Matrix Money Podcast, and I am FF, and I will be leading / hosting for today. We have our typical guys, CCM, and we also have Crypto Jar here, but we have a special guest.
Morning.
If you haven't already found out through the title of this, Yeti. So Yeti is actually from DYNEX, and he is going to answer all your questions DYNEX related. And can we bring up Mr. Yeti? Yes.
Here we go.
And
welcome, Yeti. Welcome to Matrix Money Podcast.
How you guys doing?
Welcome.
I just want to say one more thing. Yeti is an OG, like a true OG. So literally anything that you want to say, even if it's not DYNEX related, ask him because he will help you. But yeah, let's all get started, guys. I'm really excited for this. To have
Do you want to check
here.
our chat real quick first before we get started? Because then we
absolutely.
might get down a rabbit hole there.
Lit up real early.
Yeah. Let's see. We got the Pirate in the house. Good morning, good afternoon, good evening. Yes,
All the above.
That.
Yep.
Chris Hanley in the house.
Morning,
Welcome,
Chris.
sir. Let's see who else we got here. I've got to go through Backward Miner. Welcome.
Morning.
Automatic Beats, as
Yes,
always,
sir.
in the house. Appreciate you. Darren, there you go. Excellent. All right. We've got through everybody. They're talking. We'll let them talk. Oh, wait. Toxic Miner in the house. Appreciate it. All right. Sorry. Didn't mean to interrupt, but I want to at least acknowledge everybody that's here early. So go ahead. Lead us off there, FF. Go ahead.
Yeah, so if you're not already aware of the project DYNEX, they started, I believe, a few years ago, right, Yeti? You can give me the exact dates on that. But the idea of the project is not only to be a network of miners, right, and then having that sort of layer to transact the DYNEX token, but to also have a computational layer where you are utilizing the GPU resources to basically crunch numbers. Now, that's a high-level overview of DYNEX as the project, but this is why we have Yeti here, right? For him to go deeper into the weeds on what this number crunching means. And let's just go with that, Yeti. How about you introduce yourself, and then we'll go from there.
Sure. So my name's Clifford Mapp. I'm the head of ecosystem over at DYNEX, and we're aiming to showcase that blockchain can be a lot more than just a financial transaction service. As you rightfully said, the idea of our network is that obviously our coin itself is our method of paying for our infrastructure. But fundamentally what we're doing is blockchain only uses about 10, maybe 12% of the GPU. And then the rest of it is left unused from a blockchain standpoint, right? Before we even became a blockchain, we tried to build our own network and realized very quickly how much it was going to set us back cost-wise. It was going to be like mega money, and it just made no sense to effectively do that, right? So we decided blockchain would be the most logical, and then it was deciding how we were going to do that compute. And there was a few, we wanted to look at the quantum side of things and using, simulated annealing, gate-based logic and so forth. So we quickly realized that there was a few different choices. We could do it physics inspired, which is like, physical quantum computers are, or there was this really interesting path of using like neuroscience and neuromorphic networks, which is, for anyone who doesn't understand what that is, neuromorphic is just biology inspired, right? It's the same way that the human brain is set up. So huge capability of parallel processing. And that really sort of kind of drove us down that path anyway, because we were just like, well, if we're going to do big compute jobs, then this is going to suit our needs like really well. So that's what we've been doing, basically working out a way that we can harness the rest of the cards. So we use 100% of our GPUs in the lowest possible electric usage. Our algorithm's one of the lightest for mining. But that just showcases how efficient DYNEX can get, to be quite honest.
I kind of had a...
He already answered one of my questions.
Yeah, you're talking about it's the specs seem to be fairly low for a computer that you want to contribute. What would be the minimum specs that you're looking for a PC, whether it's CPU,
realistically, we can get away on our blockchain with 4 gig graphics cards. Okay. Even 4 gig graphics cards can do basic compute. Yeah. They won't quite give us the same capability as, say, a 4090 or a 4070 or even some of the 30 series, right?
Yeah.
But every little bit of compute can be used.
Is there like an optimal piece of hardware that you'd want to do that?
Right now, the most popular card, and it's actually available on our Block Explorer, you can actually look at all the registered GPUs we've got on our network, and the most common right now is a 3070. Followed by 1660 Supers, surprisingly.
1660 Supers. Oh, okay. All right. That's interesting.
Yeah. Yeah. It's quite interesting to see the spread of what our GPUs are already.
Yeah, you don't have to go high end at all. Then you can.
Oh God, no! Don't get me wrong. There are some high end cards on there. We've got a couple of A100s on there. When mine aren't in use, I throw usually some H100s on there for a while. As the pirate just said, data center cards do really, really well. But you can see here that literally the most popular card is a 3070, followed by 1660 Super, and then a P106-100, which is, what, 7 years old now?
Yeah, I was just gonna say that one is extremely old.
Yeah.
That's borderline FF type of GPU, because I think I still have some P106-90s, which are even worse, in one of my rigs. So, yeah, wow, okay.
So I had another question, if you don't mind.
Sure.
So based on like demand on the network with this compute, what happens if you don't have enough compute available? Is there like a queue, or what happens when there's so much demand that you can't handle it?
So there's actually 2 queues. There's the overall queue, and then if you're on a subscription model, you actually have your own queue. So say, for example, you run a job with your subscription model, and you basically max it out, and then you run another job, it will internally queue that on your own user without affecting the overall queue, because they're designated resources to you.
Okay. So is there a price increase to the customer based on what they're demanding from the network?
There is. We have a dynamic pricing scale for spot jobs. Okay. So what do I mean by spot job? Basically, a spot job is somebody who's pay as you go, basically.
Right.
So sometimes you might have somebody who just wants to run it once, right? They just need to validate their results. They run it once, that's it. They're off the network. And that's fine, right? We're absolutely fine with people doing that. But obviously subscription models are, you pay for a month, you get your resources 24/7 for that entire duration of your month.
Yeah.
So spot jobs are dynamically priced. Obviously subscription models are fixed.
So your customer base, like what area of the market are you predominantly targeting?
We've actually had quite a wide sector adoption already. One of them being obviously pharmaceutical, for things like protein folding, drug repurposing. There's some really interesting stuff around drug simulation as well that I've seen quite recently. That's quite exciting to see from what they can do with that. So imagine, a brand new medication coming out, and you got to wait 10 years to actually know whether that drug's been effective or not. But what if you could simulate it for 10 years and actually get those results? So it's actually a really fascinating research path that they're going down. But the amount of compute they need is off the chart, shall we say. Okay. Something that, would easily cost 50 to 100 million pound, dollars, shall I say, to set up, and then thousands of dollars a week just to keep it running. So those are the kind of from pharmaceutical side. We've also been in talks with automotive, in relation to CFD, or computational fluid dynamics.
Yeah, I can see that.
Air and liquid interacts with an object. It's a fascinating research path for quantum. Our head of quantum architecture, Sam, he came up with a piece of code on top of my conceptual work for a virtual wind tunnel on DYNEX. So that's something else that we've been pushing. We already have released the plugins so people can actually use that on OpenFoam, Rhinoceros 3D, and we're working on an AutoCAD one next.
Okay, so you have like a marketplace where people can pick up components or contribute that way?
So we have a marketplace for obviously registering your account, KYC, and obviously your API keys for running on the network.
Yeah.
Inside of there's obviously a whole bunch of resources to get you started, some example code that's available for you to run, and also a very quick sort of 3-step guide on how to get you up and running fairly quickly. So yeah, but the marketplace is, we're going to expand on it as we go, right? As we see more need for it. We know that obviously the experts area is now available as well. We have some DYNEX experts. You can, if you've got a great idea but can't code, you'll be able to go and ask an expert soon.
Oh, that's a nice one. I can't
yeah, I mean, we're onboarding the right experts. But that's something we've got to make sure that they're valid, right? They've got to go through a process of validation.
Okay. All right. That's interesting.
Great questions, Jar. I actually have a follow-up question in regards to some of the clients that you have, and then you talked about some of the modeling that you did for them. How I see DYNEX, or how I saw DYNEX originally, was that it was strictly number crunching, but when you bring up models, it always makes me think of AI. So can I personally get some clarification on the differences between what DYNEX does versus what some of these other compute resource companies do in regards to number crunching versus AI?
Yeah. So you're talking about like things like large language models, for example.
Yes. Yeah.
And things like ChatGPT, Llama, and that kind of thing, right?
Yeah.
So we are in the process of bringing out our own. So Chris has just... Chris has already.
That was convenient. Yeah, that's why I brought it up.
There you go. Yeah.
Thanks, but we're working on something that will be effectively the very first quantum-based LLM, and that's quite tricky in a quantum environment because there's variables that have to be translated from a quantum formula to something that a computer can actually read and use. We've already demonstrated something called QNLP, or quantum natural language processing. That's the fundamental underpinning that is the talking mechanism between you and, say, a ChatGPT. And that's where basically the large language model plugs into. The next was obviously transformers. Those are the things that can actually give it actions to do. So you tell it to write a piece of code that needs a transformer in order to, translate all of that into a format that's usable. So we're almost there. We think we'll be there by the end of the year. And then it's going to be a case of seeing how fast we can train ChatGPT. We know roughly how long it takes, the big players in the industry to train their models. It's weeks, if not months. What if we could do it in under an hour? That would be pretty impressive, right?
Yeah.
So it's something that we're working on.
Okay.
But in relation to what you said about like where do we stack up compared to others? So a lot, the rest of the compute sector, right, are all working on standard traditional models. So that's, very much computation like we're all understanding right now. One action in, one action out, blazing fast, but it's still one in, one out.
Yeah.
Whereas what we can do is go, I need to do 100 variables and do them all at the same time. And then they all come back at the same time. So think of it like a big spider's web at that point, right? We can spider web out to a much bigger search pattern than what you can with normal compute.
Okay.
So, do you have any competitors that are doing similar setups that you have right now?
There are some similar competitors out there. They're not doing it on a decentralized environment.
Yeah, I'm wondering on the decentralized side.
We're really on our own at the moment for that,
right?
When it comes to quantum, anyway. There are people that are doing compute on a decentralized scale. That we're not claiming that we're the only ones in that realm, but from a quantum sense, we are.
Yeah,
but the nearest competitor would be somebody like D-Wave, or IBM would be another one. There's a really interesting statistic. We put it out. I believe it was $1.20 on IBM per second of runtime, and it's 12 cents per second on DYNEX to run the same compute.
Okay. Wow. Significant difference right there.
Yeah, it is.
Yeah, it's massive.
Yeah, no, because there's a lot of the decentralized compute competitors out there, but they're not even touching the same things that you are. And that's good to really define and separate them. Because that area of the market, in my perspective, seems quite saturated right now. It's just pretty much everyone's picking up on that same time. So it's interesting.
Yeah, we knew that when we started doing the quantum side of things, right? It was a really large niche. It's almost a niche of a niche, right? Because quantum's a niche in its own right, and we're a little subsection of quantum. But we believe that there are merits to just what we're building right now, where it comes down to overhead cost, right? If we can bring that barrier much lower, that now you bring in the realm of that small businesses can start using quantum algorithms, right? Or brand new developers can realize that, oh my god, quantum's now available, I can learn how to program this thing, right? And suddenly you move that technology on. I truly believe that the only reason why quantum hasn't become more mainstream than it already is today is down to cost, like barrier to entry. It's too high. It basically restricts it to a very small amount of people that actually get the luxury to use that technology. And to me, that's the wrong way of that kind of technology becoming available. How did computers take over mainstream? Because they were so cheap, they were starting to drop in price that everyone decided they needed it.
Yeah, absolutely. Absolutely. This really opens it up.
Yeah.
Makes sense.
Looks like you highlighted some questions.
Yeah, we got a bunch of questions in the chat, but FF, I know you got like an initial time thing. Did you want to ask another question before we get to our chat questions?
No, and I'll join back in after that little time crunch. But I think let's hop into Zapirate's questions because
he has 3 of them. Here's the first one.
Yeah.
Oh, I knew Zapirate was going to ask something like this.
Yeah.
Yes, actually, that's something that I'm actively working on right now. We understand that having only 2 is always a risk, right? We had this with SRB Miner as well when we had the whole issue of them, should we say, cheating the system. We've since patched that out to make sure that can't be done, but that took time to realize, and that really showed us that there was a problem. Obviously, BZ Miner was nice enough to set up an option for AMD, but would we like more? Yes, I'd like another 2 more, ideally. 4 would give us that stability that there's a little bit of leeway should any problems arise.
Okay. Here's the second question.
Oh, I knew this one was coming. So so this is on our roadmap, right? So
before you answer the question, do you mind just explaining a little bit of proof of useful work, just for people who may not know what that is? Yeah,
that's a good idea.
So we run what we call an entangled network, right? It's proof of work, which is your normal blockchain, and then proof of useful work, which is our jobs running on our network. They run both simultaneously. So when you're doing a job for us for a client, you're also securing our blockchain by making sure the blocks, are mined and correctly verified in the hashing tables. So right now we have what we call our entangled network, and you can't do proof of work without the proof of useful work mechanism running, and you can't do proof of useful work without the proof of work part running. So if any side stops, both sides stop effectively, right? Because that's the kind of thing that happens with entanglement. What Zapirate's asking about is what we've dubbed absolute entanglement. So we're going to actually push the block hashing functions inside of the proof of useful work mechanism. And then effectively it will be pure PoUW. But what you'll do is your standing job when you're not doing anything will effectively still be block hashing. It's just, it should drop the power by about anywhere between 10 and 14% on per card, depending on which card. So it'd be a really interesting part. It's a next evolution of our blockchain, where the entanglement is so tight you can't actually see where one begins and one ends. It's all just proof of useful work.
And timeline wise for that, what are you projecting?
We're ideally hoping to have that on testnet ready, probably Q4. Probably Q4. Just because that takes a lot of pre-planning, right? We're making a massive, huge change to our network. The fundamental underpinning of how our blockchain runs as well. It's not going to be something we're going to take in, like, we're not going to rush that. We're going to make sure it's solid. We're going to put it on a test net. It might be on a test net for 3 months. We don't know yet until we start running it and see where the kinks are, so to speak, right? We gotta make sure that this is done correctly, because the last thing we want to do is not only destroy our network, but obviously impact our miners who are supplying us the hardware.
Okay, great.
Could I ask a question off of that?
Sure.
With this entanglement, you said one side goes down, the other side goes down. Basically, it stops.
Yeah.
Is there a potential of the whole thing going down?
We have had one stall out of our chain. That was really pretty much, 13 months ago now. And that came down to just a bug in the way that it was interacting with our blockchain. And so it caused one of the connectors for our mining pools to basically stop. So they couldn't access the seed node effectively. We've since solved that. We've put in extra load balancers. We've actually overkilled it. So there's, instead of having 4 points of failure, and if any of those go down, it's a problem. Now we've got 10 or 20, and it's dynamically scalable. So as more resources are needed, it can open up more of those pipes and allow those connectors to come through. So we've ironed that out now. We haven't had any problems for over 12 months on our blockchain.
Okay, that's good. So you added adequate redundancy, basically.
Yeah, yeah. We just added more. We didn't realize that once it really got busy, and that was around when we had our all-time high last year, June, July sort of time. We had 22% of all of Hive OS's GPUs on our network. It was probably 500,000 GPUs at that time. We weren't even live at that point. We were still beta testing the job systems. And obviously we found that we had a bottleneck somewhere and we needed to fix it. So we went off, got that solved, and since then it's been no problem at all.
Okay. This is his third question.
Oh,
I don't mean to laugh, but I get the question. I truly do.
So all of our client data is completely encrypted, right? Both ends, end to end. We don't take any risk on that. Same when you run a job. If you don't want it routed to our server for delivery, you can actually have it delivered to your own server. Just specify it in your API key, and it will send it directly to you instead of us. So that obviously gives a little bit more security around what jobs are going where, right? So if you're a company and you're running something super, super secure, I know, you've got some sort of secret project that's not in, IP locked yet, and you want to make sure that it's safe and secure, we can send that directly to you. It's all completely end-to-end encrypted, and
it's not cached anywhere during the.
Sorry,
it's not cached anywhere during the processing.
No, and effectively it's quantum energy states. So unless you've got the decoding pattern for the energy state that you've just sent through, it'd almost be impossible to decode it the other way. Okay. I mean, you could brute force it. It'd take you a while, but you know, the way that we segment it as well, it comes in slices to you. So unless you get all the slices, you're also going to have a problem as well. So it really does depend on how you're running that job. And we can also geo ring fence. So if you want only, you know, machines in your local country to run that job for you, then you can.
So the encoding part, I'm assuming you chose encoding over something like, for example, encryption for speed purposes.
No, like you said, there is an encryption layer involved. It's just our own. It's our own layer of encryption that runs through our own system. So we run a form of, you know, quantum-based encryption. We're actually in the process of actually fleshing out a public release, shall we call it, of quantum encryption using DYNEX. It'll be very new. It's a whole different way of thinking about encryption, which is, you know, I know that people are all wanting me to get, you know, leaky about new things coming out. So, I mean, why not? Why not? We tell you what we're going to do. But quantum encryption is something that's a bit close to home, right? I do act as obviously DYNEX's IT security guy, right? So for me, thinking outside the box is kind of natural in that respect. And I think even FF and I have spoke about this a number of times, right? Security is one of those things that really drives me for crypto, right? Like there's a lot of good, but there's also a lot of inherent dangers, especially with something as powerful as a quantum PC. Right. So, I mean, we might as well, you know, talk about the elephant in the room, because you know that this question's going to come up next. I guarantee 100%. It. I'm almost 100%. Waiting for it to pop in the chat now.
Yeah.
Can a quantum machine break SHA-256? I guess is what you want to know, right?
Yeah, that's what I want to know.
Basically, what most people want to know.
Yeah.
I mean, that's quite a diverse subject. We wouldn't allow running it for what? Right, because we've got an ethics committee and a load of, should we call it, rather nasty security, making sure that you can't abuse our service.
Okay, so before you continue with that, like you were talking about privacy and how everything is end-to-end encrypted. How would you actually know that it's happening?
I was going to ask the same question.
Same. Well, you got it.
So all of our encryption, right? Obviously, when it comes to the quantum side, we use a quantum key map to create basically like a public key, right? It uses the same logistics basically as what we already get now, private and public keys, right? The difference is that it is a multi-dimensional quantum key, which traditional computers can't see over more than like 4 dimensions anyway. So if we just go to 10, then nobody would be able to break it unless you're on a quantum variance. Even that would be a struggle, given that it has, you know, energy states and superposition to actually dictate where those keys actually sit. It's crazy efficient and crazy, like, obscure type of coding in that way. We did it that way because there is too, shall we say, there's too little talk around how bad quantum computers could be when it comes to encryption. Right now, people think that just because like IBM's got 1,000 qubit, that's, you know, not enough to break an encryption layer. Well, now imagine that on a scale, times it by 100, times it by 1,000.
Yeah, that's
now we have an issue. Right, and people don't talk about this nearly enough. It's something that's, you know, I talk a lot about when in the staff calls. Right, we're always on about making sure we're one step ahead.
Yeah, the idea is scary. I think that's why a lot of people are not talking about it. But the threat is real, and I think the possibility
it really is, right?
Yeah.
You know, you think AES, right, or even RSA, right? Let's take RSA as an example.
Okay,
right?
Sure.
Most people go RSA 1024 and think that's safe. Most governments use RSA 2048 because they deem that as higher security as humanly possible. But we're going to have to start looking much higher than that. And I mean that legitimately. We're going to have to start looking higher than that, or redefine a new way of standards for encryption.
Like a quantum enabled.
I know that they are developing this, at least in the U.S. government on the NIST end. When you talk about using RSA 2048, that's the FIPS 199 requirement. Again, I'm talking government stuff because, I mean, full disclosure, I've worked for the government, at least U.S. government, when it comes to cybersecurity. So those requirements, yes, I think that they need to be enhanced, but I don't know if they're going to actually help, because you bring up a good point again. Before I head up to this meeting, I want to mention this. You talked about superpositioning, and a lot of people who don't understand quantum mechanics, not just quantum computing, but quantum mechanics on the physics level, probably don't understand what superpositioning is. So because of superpositioning, I'm going to explain it just very briefly, high level. When you have computing, you have ones and zeros, right? So the zeros are essentially false, the ones are essentially true, and you combine this system of true and false to define everything in computing. That's called your binary, right? That's ones and zero twos. Superpositioning is when you have the zeros and ones essentially at the same time. Now, I know for quantum mechanics, that's how it's defined. So zeros and ones are essentially the same time. That's why it's called superpositioning, because it's like one over top of the other. But then in regards to computing, and Yeti, you can correct me on this, I believe that it's introducing another number, essentially, like maybe you could say like -1 or something, or however you want to define it. So now you have like this triplet instead of this binary system. And it because encryption at the base level still relies on binary, right? I don't, and this is just based off of my own research, security research, I don't even know that enhancing it to, like, let's say a 4096 is going to give you enough protection against the quantum.
I mean, it might buy you maybe 10 years.
Right.
If you needed time to figure it out, it would buy you some time. But you are right. Like, we need to consider way more than just ones and zeros these days.
Exactly.
Like, we really do. They're like quantum and next gen or next generation technology, right? That's what effectively we're talking about. Next gen technology, and that includes what we're doing, is kind of where they need to be looking at right now. They need to be looking at these kind of services and going, okay, so now they've proven that this can actually work. Now, how do we make sure that we can never be attacked by that, right? And we've had discussions with security experts. We've had discussions with, you know, some big people around this exact conundrum, right?
Yeah.
I sat on a couple of X spaces quite recently with some really high level, like, quantum guys, and they all said the same. Like, they're not picking it up nearly fast enough, and it will be somebody using something like a quantum computer that will make that snap of, oh my god, we need to deal with this right now. Like, and then it'll suddenly move on. But we want to make sure.
That's all kinds of scary. I'm just saying.
Oh yeah, absolutely. We understand that. It's why we have an ethics committee in the first place, because we need an unbiased third party, basically, to say, okay, this is kind of gray area type of compute you're wanting to run. Well, what are you wanting to run it for? And then they work it all out. And if they're not happy with it, then it doesn't get run at all.
Right. Is this something that you've experimented on your own network by yourself and just tested it out to see what the possibilities are?
We have done some RSA testing. We flat out refuse to code a piece of code that could be used maliciously like that.
No, I understand that part. Yeah.
The one thing that I've got to do, though, is everything that runs on our network leaves digital fingerprints.
Okay.
Right? And so we need to at least emulate what it's going to do to get that digital fingerprint. So while we were doing beta testing last year, a lot of what I was running was fingerprint testing to get those fingerprints to lock into our security systems.
Okay, so then that's how you would identify what's
correct.
Running.
And then as new things happen and we spot them and they go to the ethics committee, if it's turned around and said no, then that's a new fingerprint that gets added to the system.
Okay. And like reactionary? Like when you identify this on the network and it's already running, how long before you
it's literally within 1 second.
Oh, it's that quick.
Wow.
Yeah.
Okay.
Yeah, the pre-processor basically deals with it.
Wow.
So as it's pre-processing ready for our network, which is where it slices it up and delivers it to our distributed network, that's where it locks in and goes, no, you can't run that. 1 second.
Wow. Okay.
Yeah.
All right.
Yeah. It's a very unique solution to an age-old problem of how do you stop misuse of a system, right? But when you've got something as powerful as ours, you need that reactive state like within that 1 second, because 1 second of runtime could be devastating.
Yeah.
Do you know what I mean? So we have to be very careful when it comes to that.
You've touched on SHA-256. Is there a fingerprint for that? Have you already gone through the process of identifying?
Yes.
Okay.
Yes.
All right.
To say that I would love to have a chat with everyone who says they're quantum resistant is an understatement.
Right. Yep.
Because I bet you they're not.
Yeah, and how do you even do that? Like, how do you even prove that it's quantum resistant?
Well, exactly. Unless you've got access to somebody like us who could potentially work with them to offer that potential service, right? Where even though that's almost like pen testing, right? At that point, we would be open to that kind of thing if a blockchain came to us and said, look, we want to test our quantum resistance, right? We'll sign the paperwork. We'll make sure it's all covered under a pen testing agreement, right?
Yep.
Would we do it? Yes, because it would be a business-to-business service.
That's a really good use case as well.
Correct.
To identify the blockchain, the capabilities of it. Is it truly quantum resistant and everything else? Absolutely. That's a great use case.
Yeah. I mean, it would have to be something that we all agree on. Right. It wouldn't be just us going and randomly testing networks that say they're doing it, because that would be unethical.
Right.
You know, there is a fine line between, you know, pen testing and actual malicious act. The difference is that you've got the permission to do it. Right. So from my perspective, as long as everything is signed and we've got agreements in place, then yes, we would happily look into that. But we wouldn't release any of that code. That's something that we wouldn't do, because that's just, you know, lighting a fire basically.
Oh, absolutely.
And pouring gas on it.
Yeah. So like a lot of this stuff, I already know I'm going to have to rewatch this interview because a lot of it's going over my head. Still trying to process it myself. So like timeline wise and everything that's going on with DYNEX, you are definitely unique. I didn't realize how unique your project was until you spoke more about it. Because I did look at it when it first came out, I think about 1.5 years ago, and I did mine it a little bit, and I'm holding it. But like roadmap, what else is DYNEX planning on doing with?
I mean, so we've been announcing our advisors and strategic partners recently. We've pretty much announced all the advisors now. The last one today, which was the Enigma Fund. They're coming on as a strategic partner to help us open some doors to new clients. We've announced quite a few partners recently, and the difference for us is that our partners are partners who are actually going to be, it's mutually beneficial to both parties, right? We're not just announcing names for the sake of announcing names.
Yeah,
they're actually there's going to be a purpose behind them.
Right.
So over the next few months, like I said to you before we came on, I'm flying here, there, and everywhere. I'm certainly racking up the air miles this year. Next year probably is going to be even worse. But you know, the only way that we make people aware of what DYNEX is doing is to get out there to the events, to be available for interviews like this, and to, you know, be available to everyone.
Yeah, and awareness is definitely key, and separating what you're doing compared to compute and AI and all the other projects is definitely very useful. Having this conversation is very useful. So go ahead.
I was just going to say, we still got questions in the chat. I don't know if you want to get.
We should definitely get through.
Feel free.
All right. Well, here's Rizal. I'm sorry if I mispronounced your name. But here's his question.
So, are you guys working with any big corporations now in case of adoption? Yes, we are. We've had some very interesting. I'm going to get in so much trouble for this one. we've been talking with some universities around running potentially some DYNEX training courses.
That's awesome.
Which will allow people to learn how to use DYNEX, and then build out showcase pieces as well. So that'll be coming soon. I'm definitely going to get in a lot of trouble for that one, but I believe that's going to be a great thing for us, right? Absolutely. I believe it's a great thing for adoption in general, because it'll be really one of the first to really go to that length in order to make people understand our network, right? Deep level understanding I'm talking about here.
Yeah.
And that's
you're targeting the right sector, the universities. Yeah, people are already learning and educating.
Yeah. I mean, there's only so many quantum machines in universities right now.
Absolutely.
There could be better options for them, especially from a cost per student perspective, right? Because then instead of paying, God knows how much just to keep this thing running, where, you're chilling it down to absolute zero, and you got to have specialists running it all the time, and you got to hire those people. Now they'll be able to have a service whereby they would already be on here or on the network and just be able to run their jobs. No problem. Just 24/7, they'll be fine. And it now opens doors up to, universities that didn't have quantum availability to be able to potentially offer that service now.
Yeah, do you see that as a major hurdle because you're in such a niche of a niche?
Yes.
Just getting awareness.
Not just awareness, but actual people with the capability to understand the technology.
Yeah.
Right? Because quantum is a niche, what we've now got to do is effectively train the next generation of quantum coders. Right? Now's the right time to do it. Oh, look, my friend Caveman's arrived. He's a good man. He's a good man.
Yeah, Caveman, I agree. I was saying that earlier as well.
And here's the next question from Peter.
Yep.
Expecting to go live.
So when are we expecting to go live? We're already live now.
I was going to say, I thought that we were.
So we actually went live 13th of December. 13th of December we went live. Which is when we flipped the switch so that we weren't on beta testing jobs anymore. It actually went to a payment module. And then last month we activated all the subscription models, because we understand that companies aren't going to want to deal with the crypto side, right? We understand that. They care about just, can they pay in fiat and just use the service, right? They don't care how we do the rest. They're just interested, can they use it? So we basically built a fiat on-ramp for subscriptions for our enterprise customers. And then we have a dispenser system that actually buys DYNEX on the open market.
I was going to ask.
And then flows that into the block rewards, thus effectively replacing our emission curve. So we've already, by just what we're putting out now, we've already extended our emission curve by an entire month.
Wow.
Which actually, considering how our emission curve runs, a month is quite a lot, to be fair. And we're hoping to extend that further and further as we onboard more and more clients.
Okay. That's interesting.
Yeah.
Bacon, eggs, and hash has the next question.
I love these questions. So coherence and any concerns maintaining it. In relation to quantum coherence, so the best bit about neuromorphic quantum, right? Inherently, you don't get the quantum variance quite the same as a physical quantum. So we don't need to do quantum error correcting, but we have our own version of quantum error correcting as well. Because we're on a distributed network, somebody could turn their rig off halfway through a compute, right? Which would be devastating, because then the data comes back to you and it's all broken, right? So we actually bring on extra miners. They sit sort of in a pseudo state where they're not quite calculating, but they're still doing PoUW, right? They're in a hold state. So if any of the data comes through and it's inaccurate, it basically picks one out of the standing waiting and switches them round. And then we'll recalculate that chunk of data literally instantly. It's all hands off. It's very, very capable. So, I mean,
You say instantly, but how instant is it when you got to
about 0.4 of a second.
Okay.
Holy crap.
That's instant.
Yeah, it's pretty fast. Like I've seen it where it just drops half the packs because like one miner that's been, got 8 GPUs might be doing a quarter of the job. It drops off. That chunk of extra workload that's sitting there waiting is directly there, almost 1-to-1 at the moment. So if one drops, one takes over, one drops, one takes over. It's very, very efficient.
Nice. Okay. Let's keep flipping through. I don't know if you want to, this isn't really a question, but.
Oh,
I think it might be an insult.
Where to begin with this one? So I've spoke about this before, right? Flux is doing something similar, but not something similar, right? It's compute, but it's not the same as what DYNEX is doing. If you've got Flux at one end of the compute scale, right, they're trying to do a full infrastructure system, right? So that's cloud-based services, storage, VPN, the whole industry, right? So they're trying to take an entire Web 2 subset of functions and switch them over to Web 3. So Zapira actually does the perfect one there, right? So you could fire up a DYNEX Docker on Flux if you really wanted to. I mean, I personally use Octaspace. We already have direct connections into Octaspace with DYNEX as part of our partnership. You can actually use the drop down, select DYNEX SDK and hit install, and it will deploy an SDK straight to Octaspace's infrastructure. So yes, you can do the same with Flux. We are potentially looking at talking to Flux about dropping our SDK on their launchers. I'm very open to that. I don't see why we shouldn't. But they're basically two opposite ends of the scale is the best way to describe it.
Well, only because it was talking Flux here, I'll put in the reply that he put in there. Any last thoughts?
Bigger is relative, right?
That's
Flux is very contained in this one little box, right? We're still finding out where our limits are. We still haven't found one yet. Every time we think, oh, we'll run this, it should really test the network hard. It kind of comes back and then says, no, thank you. There's still plenty of room left over. Like we just broke our own record in max cut again for the third time in like a month. We just keep pushing that number up slowly but surely. And
that will also just increase as you get more GPUs on the network, right? So
yeah, I mean that's the thing, right? Our network it's technically infinitely scalable,
right,
based on the network size. So if we had 500,000 GPUs back on our network again, like we did back last year, then it would be almost 5 times what we've got now. So of course it's going to have it's even more than 5 times the computing power because of the way that we slice up the compute units.
Okay, so you have about 100,000 GPUs right now.
It's 100 hang on, I can tell you, it's 124,579 currently.
Okay. So out of that right now, how much is actually being utilized?
About 1% is
1%.
Currently all like literally always used, and that's quite a lot considering, right? That's considering that we've only had subscriptions up for a month.
Yeah.
Well, technically 2, but we have to wait 30 days before we activate the dispenser for fraud check-in and all that lovely stuff. So, but realistically, yeah, I mean, we're only using 1% right now. And that's the crazy part, like really crazy part. Can you imagine what it's going to be like when we're running like 70% of the network or 80% of the network?
Yeah.
The block rewards are going to be insane.
That's what I was going to ask.
That's going to be where the money goes, because obviously the dispenser is going to get really busy really fast.
Yeah.
Like when I run spot jobs, you can already see how fast the dispenser can act as well. Like it snaps up immediately and just starts dispensing. So if I ran a really big job now and it was like a couple of $100, that would be dispensed over, I think it would be over the next 6 blocks once it's done. So it doesn't just drop a huge amount in one go, because obviously that's going to then misreport our calculations and calculators that work out how much DYNEX is making, right?
Yeah.
On like hashrate.no and other services like that. So we've actually come up with a way that it spreads it out over a few more blocks to make it a little bit more fairer as well.
Yeah, you're spreading it out amongst the GPUs. Huh?
Yeah.
Patriot Caveman has the next question in line.
Is the DYNEX wallet ready to use? Well, I've got one here.
Hold on.
Branded DYNEX as well, funnily enough.
Oh wow,
that looks like a one.
Yeah, so this is a 1 key.
Yeah.
We're actually working with 1 key right now to activate the rest of their hardware profiles with DYNEX available. Their wallet, their desktop wallet, is working as well, so you can use that. We have our own core wallet that works fine. And then obviously there's the web wallet. Now, I suppose I could drop another bit of interesting news, something that nobody even knows yet.
All right, let's do it.
Yeah, do it.
Okay, 1 second. Let me just drop this in here a minute.
I'm wondering if it's the question I had, but I'm going to let you do it.
Oh, no.
No, can't even be. Okay.
No, this is something that we haven't even talked about yet publicly.
And there you go. Backward Mine has got FF's back. Yes, FF showing off his big brain right there. Yeah.
Only occasionally.
Oh, yeah.
I'll pop that up.
All right, hang on. There we go.
Ooh, there we go. Ooh, what do we have here?
Yes.
Oh, wait.
So a domain?
It's a Web3 domain. So we have just purchased the DYNEX TLD. So coming soon. Now I've got to roll this into our roadmap. This was not something that was originally planned. However, what will be coming is a DYNEX name service. So a bit like Ethereum's name service, where you can just type in an address and it resolves to a wallet.
Nice.
DYNEX is having the same, and it will work with not only our native token, but effectively, if we get this right, it should also work with our wrapped token as well.
Oh, perfect.
And that's going to be part of a brand new partnership that I'm working on right now with exactly who's on that screen, which is Decentral Web. Okay. Decentral Web guys are really fantastic. They've helped us a lot to understand the whole Web3 infrastructure for name services. It's certainly a new field for me and some new understanding. But what will actually basically be is that you can have, say you wanted ff.dynx to be translated to your wallet, then you will be able to basically grab that for yourself and have that tied to your wallet.
Oh, that makes things so much easier for the user, especially if they're not crypto.
For new users, it's going to be really easy to use. And that's something that we're very much aware of. Ease of use is important.
Yeah.
And so that's why we've took the initiative to research this. This is, you do realize nobody has seen this yet, right? Not like I'm probably
I'm really happy that you showed it right now.
I'm probably going to get in hell for this one. Hey,
I'll leave it on the screen.
I'm living up to my
screenshot it.
Take it.
I'm just living up to expectations. People want me to leak stuff all the time, so why not do something really cool on this, right? So the idea of the name services will just be a brand new feature to make use a little bit easier for new users. And of course, some of the OGs might like to just shorten their wallet addresses so that they can go, I just send it to this address and job done. Like much easier, much quicker. Gives us a little bit of interaction with Web3 as well, which is something that obviously with our wrap token is going to become a little bit more prevalent. So instead of building it all out ourselves, it made no real sense to try and get all the infrastructure ready, understanding all the technology. It was better to build some kind of partnership and then take it from there. So that's something that's coming. I'm like I say, I'm probably going to get in some trouble for that one.
It's gone. I took it off the screen.
Yes,
thanks for sharing that.
Yeah, thank you.
And yes, we are live still. We are live.
You were talking about a wrap token. Can you explain that a little bit further?
Yeah, sure. So we understand that obviously exchanges are a pain to get on. They're not only really complex paperwork and some rather large negotiation, as FF knows all too well.
Yes.
But the prices that they charge are insane, right? People don't quite realize this, but just say you go, let's not even talk about the top 50. Let's just talk about 51 to 100, right? On the exchange list.
Yeah.
Now you'd think that that would be a reasonable cost to get on, right? You're looking at anywhere between $40,000 and $65,000 just for a low end exchange.
Yeah.
Now let's talk about the 25 to 50 range. You're looking at over 100 grand before you even start talking. Right. Now let's talk about the top 25, right? So top 25, you'll be paying anywhere from 150 grand to, well, top 5, you're looking at probably $500,000 worth of investment to get on an exchange that big.
Like the investment that you're talking about, is that just to provide liquidity to the exchange?
So that is the liquidity,
the
listing fee, and also marketing.
Okay.
Yep.
Because they expect a certain amount of liquidity for airdrops and promotional material, you know, giveaways and stuff like that.
Yeah. Okay.
Right. But it's crazy.
It's incredibly expensive.
And people don't realize like that. That's how much it costs to get on exchanges. So we looked at a wrapped token, right?
Okay.
We're first on Ethereum. We will be looking at others down the road. If this has been a success, we'll cross chain it and do it still that way. But it's a 1-to-1 bridge. So one goes in, one comes out, basically either direction. But it exposes us to decentralized exchanges, which we then just provide the liquidity, and we can run our own pairings on exchanges. Like, you know, it's a much easier process to list on a decentralized exchange than it is to list on a centralized exchange.
Right.
And then all we've got to do is just you use our bridge and you turn it back into DYNEX afterwards. So there's a tiny fee, but that's to do with Ethereum gas, unfortunately.
Yeah,
which is why we're also looking at other chains. So, you know, maybe Polygon might be an option because it's very compatible with what Ethereum does anyway. It's not too bad. It's quite a fairly straightforward one. Base might be another alternative, right? Coinbase's own platform. BNB might be another option. But yeah, or even Solana would probably be the other one, if we can, you know, guarantee that they're always going to be working.
Wow, the shade has been thrown.
You just made my day. There you go.
No, but I also want to touch on, before we hop into some more questions, why all of this is important. As you know, Yeti has also explained, I've tried to help the DYNEX team. I won't say the exchanges that I do have direct contacts to, but
let's just say it's been a challenge.
Yeah, it's been a challenge, ongoing too. So
yes,
the reason why this is important, and I'm going to like relate this to the project as a whole, is that when you're able to scale up your network in the grand scheme of things on the money making side of it, then you're able to introduce more hardware to the network, right? Because now your DYNEX as a token is worth more, so the incentive is higher for people to mine, meaning that they will join the network, correct? And then that basically snowballs to a point where now DYNEX doesn't just have 130,000 GPUs, now they have 200, 300, because the incentive is now there.
Correct.
And then your compute service can now do true quantum work. It can do the work that DYNEX is intended to do. But we as a community, right, this is why we have these conversations here, why we interview these people, is so that we can garner up that support, so that the incentive gets to that point, right, where we're all like, okay, I'm going to turn on my rig, I'm going to support DYNEX, and I'm going to, you know, hodl the coin, right, so that their project can do what it's intended to do. But the issue is us as people, in the psychology is we see the coin going down, right? And then we're like, oh, we need to go switch over to whatever to be profitable, etc. But if you truly believe in the actual project of the coin, then you need to consider that. And that's why I just want to kind of tie it back into the project, because I know sometimes we get kind of off subject and we're like talking about exchanges and money, but it's a big point on trying to get DYNEX to where we all want them to be, because I definitely want to use the product. I have other questions on the use of it, because I have some things that might seem nefarious, but they're not. We'll get to those questions later. But and the only way that we're going to get there is to spread it, make the incentive good for the miners and the proof.
No, absolutely agreed. That is fundamentally what we're, having the action to do, is that the more jobs that run on our network, the more clientele we bring on, the more subscriptions that come in, they all funnel back into the DYNEX ecosystem, and 70% of that is going to the miners. And then we've got a rebate service inside of our marketplace that all the holders that register for that, and it's done with a proof of reserve balance file from your wallet, they get a proportional share of a 10% rebate. It's not staking, right? Because you don't tie up anything, you're not locking anything away, you're not doing anything, right? Your funds are still in your wallet. The reserve balance file just basically says, here's how much I've got in my account in an encrypted string, basically, to tell our system that it's valid, and then you get your proportional share. So, and then the 20% is shared between us and our foundation. So it's 18% to us and 2% to the foundation.
Would you introduce a staking component to incentivize just locking in liquidity too?
We have considered staking, but we're worried about the fact, obviously, we're a European registered business, and we have MiCA considerations to worry about. We're already having some concerns around USDT at the moment, so we might actually have to look at USDC as an alternative temporarily as well, activating that as another pairing in Europe until we get a proper answer around it, because right now Tether is basically turning around to the European government and saying no, which is obviously they're going to get blocked out of being able to use it in Europe, and then we've got a problem.
Right.
So hence the reason for our DEX idea of going on decentralized exchanges for one, but also why we're also looking at USDC as an alternative as well, maybe just for the European markets.
Okay.
Interesting.
Yeah. MiCA considerations has caused quite a spanner in the works, to say the least. But thankfully we've got, and I met these guys over in Dubai, actually, when we were over for Token 2049. They're fantastic. There's some Web3 lawyers. They specifically focus on Web3 and the technology around it. And they give us regular updates. They're big fans of DYNEX and what we're doing, and so they always keep an eye out for us and say, oh look, we've had some of this news come through the grapevine about MiCA, or there's something new that's coming out, want you to have a read of this, and they send me a whole bunch of material and give me their consideration. So it's really nice that we've built those relationships up now, right? That's one of the best things about going to these events. Me and FF met at Miami, first person I spotted out of a crowd. I was just like, I'm heading over that way. I've got to go and say hello.
I'm easy to spot. So,
well, the big giant red F gives it away.
The red hair.
Yeah, exactly.
We're over an hour in. Are you still good, Yeti, or what?
Yeah, of course I am.
Do we have more questions in the chat?
Yeah, here's the next question that was in line here.
Has anyone forked DYNEX yet? Yes, there actually is one, but it forked before we started doing machine learning. So they're basically what we were 14 months ago. I think it was. Don't know how much they've really got into moving their project on, other than just firing it up. But we wish them good luck. No, there's no worry about that. We don't have a problem with anyone forking our technology from a blockchain perspective. They're still going to have to integrate the services, though, that obviously we've got involved in with our system. So it's not as straightforward as just going, I'm going to fork DYNEX and run quantum jobs. because obviously we've got intellectual property rights on the technology that we've done.
Okay.
So yeah, and that's it's not the blockchain side. That's all open source.
Yeah,
it's the security aspect, the encryption layers, and the job delivery mechanism that is ours. The rest is all open source.
Okay, that's good. It's good to know.
Gotcha. Here's the next question in the list here.
It's actually a very good question, right? Obviously, as a miner, you would love us nothing more than for us to charge an absolute fortune, right? And make good money. But there's also a responsibility for us as a business, right? We first and foremost are a business with a blockchain. We don't consider ourselves a crypto project per se, right? We are a business first and foremost. We built the business up before we built the blockchain. So first and foremost, we have to look at it from business considerations, right? Yes, would we love to be able to pay miners massive amounts of money? Absolutely. Right. But we will get there with our clientele, right? The more clientele we run, doesn't matter if it's cheaper, you just get the volume through.
Right.
If you're running 20, 30 times more than what we are today, then the fees would be ginormous effectively, right? Then nobody's going to be saying that they're getting paid less. It really does come down to that we're trying to break a mold that quantum's expensive. Now we're offering a service that basically changes that meaning. And that does mean that we've got to do it cheaper than everyone else.
Yes, that makes sense.
The beginner's block. Yes.
Next question right here from Chris. I was wondering if somebody was going to ask this.
Oh man, I'm so getting in trouble today.
You can decline, Yeti. You can decline.
No.
Yeah, seriously.
I've yet to ever decline a question. So, trading bots, right? It's not quite running a trading bot like how Chris is asking there, right? Because you can't run traditional programs on quantum. It's not quite like that, right? Obviously, people are still understanding how our technology works, and I don't have a problem with explaining this. So the way you'd have to run a trade bot is it'd be a hybrid. You'd run it on your own equipment, but you would train it using quantum-based algorithms. And here's the bit that's really cool. If you wanted to predict the price of Bitcoin, most people look at the last 3 months to have a look at what the charts are doing, maybe 6 months to get a rough idea of what the chart's doing. I'm not a trader by trade, by the way. I don't do trading. But you could effectively give it the entirety of Bitcoin's history of price and then ask it to do the predictive model on it. Now, with that much data, your predictive model is going to be a hell of a lot more accurate than if you're looking at only 6 months.
Absolutely.
Right? So, of course, it can see things that maybe we can't, right? Because you're the one coding it, right? So you code it to look for a specific variable or a specific pattern, right? If you're looking at over from the entirety of Bitcoin, there's every chance that you miss something, right? Which could screw your entire data up. Whereas quantum, obviously, you can just feed it all that data and then just have it get really, really into looking for patterns. And, it could find you that every 3 years there's a bump in the road where you could make a really good 20% or something, right? We might not even see that because it's over such a large length of time that, that's how quantum really helps. And so I would do the training mechanism on quantum and then feed that back into an existing trade bot model, because then it's effectively the best of both worlds. You get a normal trade bot that you can run, but effectively its brain and how it works is all trained on DYNEX with quantum algos.
There's a lot of possibilities with that one.
Yeah, huge.
Massive.
Huge. Yeah. Here's the next question from Retro Mike Tech.
What or who got you into DYNEX originally, and what was the reasoning that drove you to it? Oh, Mike, I knew one person would come up with a conversation piece like that. I knew it. Oh, Mike. So I found DYNEX, what was it? January 23. So just after they came out of their only CPU phase, basically, and just after they had an ASIC problem, which is why the actual max supply is 110 million and not 100 million, because DYNEX took the appropriate action and increased the amount of supply within that first 3-month window because of the ASICs coming on, because it was unfair to the rest of the network. So they took appropriate action. But what got me into DYNEX was I work a lot in statistics, right? My normal job, it has a lot of statistical data. And I really like the idea of converting a lot of that statistical data via quantum algos, right? Because right now we have to have 4 servers just to do all of our statistics. Right? It's a lot of number crunching, right? Mm-hmm. And it costs us a fortune. But what I'm doing at the moment is actually recoding all that to use DYNEX services. So it'll actually number crunch it all for us and drop it all in for us, which would be a lot easier. But that's what originally got me into DYNEX, right? And then last year, it was about, when was it? It was just after I got back from America. So September last year, right? Obviously, I went out to visit DYNEX. I actually did a video, chump change, put it on his channel. And I went out there and visited them with a potential of getting an understanding of what DYNEX was about, who they are, why they're trying to do it all. And, we started talking about whether, I'd already been talking about DYNEX on some YouTube channels, done some, bug bounty stuff for them. The natural evolution, obviously, once we'd gone over there, was, well, can I do any more to help? So I not only started learning how to code quantum-based algorithms, which Sam, bless him, he is the ultimate patience. He's got ultimate patience with me. I'm not quite as young as I used to be for learning, right? It takes a little bit longer these days than it used to. But yeah, they wanted me to join then, and I said no, I want to stay independent, right? I wanted to give them an unbiased opinion of their technology, right? Give them some perspective from outside of the corporate bubble, right? I thought that it would be really helpful for them. And then obviously January, just gone, I flew out to America and did an interview at the NASDAQ for Bloomberg TV and Fox Business. From there, it was like, well, I'm already doing interviews. I'm already helping around the place. I'm already doing, a lot of media appearances for them. And they're about to announce their team. Well, wouldn't it be pretty cool, if we start talking about it? So we started talking about it, I think it was February, March time. And then basically I signed my contract then and just haven't stopped since, basically. But what drove me to it was the technology. Like I've been in crypto for a while now, right? It's actually 10 years I've been in it. And you reach a point where it's not just all about the money. Don't get me wrong, the money's nice. But I also look at what blockchain can do and how we're still in its infancy, right? We're not even a mature piece of technology, effectively.
Yeah.
But it's really cool to see now that we're now starting to see the next evolution of blockchain, where things are actually not just currency, it's other things are being built on blockchain.
Yep.
Amen to that.
All right. Here's the next question.
That's a good point. I didn't mention Nvidia Quantum Cloud, mainly because I don't have much reference from a use case, right? Their SDKs are still pretty early. I don't know if there is any actual public SDKs for Quantum Cloud yet for simulation to be able to test it, but obviously D-Wave is the closest. We're fully interoperable with D-Wave. you to run D-Wave code on DYNEX takes 3 lines of code change. That's it. So
Nice.
you can then run Cubo and simulated annealing and Ising models all directly that you would have done on D-Wave directly on us. That's why I use D-Wave as a direct competitor, because they're so interoperable with us.
Yeah.
It's almost like a very similar system at that point. But Nvidia Quantum Cloud, I would love to have a play with. Like I've already said to a lot of the staff, like at some point we've probably got to go and rent one of each
and just test
and
it out.
drag race everything.
Yeah.
But it's trying to build a piece of code that's universal. That's the big one, right? We could drag race D-Wave.
Yeah,
absolutely we could. I don't think it would be a fair fight, realistically, but Nvidia's Quantum Cloud, now that's an interesting concept, right? Because they went massive.
Yeah,
like they went really big. So I'd love to drag race the pair of them, to be quite honest. I've always said that if anyone has any kind of compute and they want to try drag racing it for a bit of fun, I don't mind that.
I'd also imagine that I'd imagine that because they went so big, their cost is also going to be big too.
Oh my god, I could only imagine how much that thing's.
Yeah,
I think it's like 80 megawatts or something that they're using. Like it's ridiculous power consumption, right? And that overhead is expensive. That's where we're able to drop those costs, because we don't have the overhead.
Right. Yeah, your efficiency blows them out of the water.
Yeah, it comes down to, a lot of it just comes down to the lowering the barrier to entry for normal people to use, right?
Mm-hmm.
There are going to be people that could have done quantum research that probably were put off by price in the last few years, right?
Oh, for sure.
We could have missed the next Einstein. We could have missed the next, Tesla or Stephen Hawking, because that barrier to entry is too high.
Mm-hmm.
That's not good. That's not good for humanity. That's not good for us as a species, right? Those kind of people only come round once a generation, right? They say there's, I think it's like 10 or 15 geniuses in a generation, right?
Yeah.
So we got to find those diamonds in a rough and let them loose with new technology and for us to get better understanding of physics or whatever their research path is, right? So I think that lowering that barrier to entry is exactly where we've got to be.
To that point on pricing, it kind of leads to one of my questions. How exactly is the pricing model for DYNEX? Like,
sure.
Yeah.
Which side?
So basically the spot. I think subscription is probably a little bit easier to explain, but like, for example, if I have something that I need compute for, and it takes me days to get the solution that I'm looking for, is it based off of a time model for spot, or is it based on something else? Or
so it dynamically adjusts based on usage on our network, right? There's a base cost. And then obviously it's plus or minus, obviously, when it comes to how much usage. So at 1% right now, if you were running it for an entire day, it'd be like maybe $200, something like that. Depends on how. See, a job might take 18 hours to run, but if it doesn't use a lot of resources, it just takes a lot of time. Effectively, that's no different than you pushing it up higher and running it for a shorter duration. So realistically, you'd do better just turning up the wick and letting it run full bore for a short amount of time than run it long.
And I guess that was going to be my second question. When you say turn it up, can you select how much compute resources?
For a spot job, yes.
Okay.
For a spot job, you can request the entire network if you want to pay for it.
Okay.
I mean, I've only done that ever. Well, actually, I did it twice. Once almost crashed the network completely. Which kind of freaked the boss out a little bit too much. The second time when we did it, though, it went off without a problem. I required the entire network. I ran a compute job. Took it didn't actually. It took, I think, 4 minutes.
Okay.
Start to finish for the entire network to do it. It was massive. Like it should have took weeks on a normal PC to do, and we did it in 4 minutes.
So are you seeing where maybe I'm headed to on like the nefarious side of things? and it's not quite nefarious, but it can be. So I'm going to talk about the part that isn't. And Yeti's probably also aware of this, but there are wallets out there that show you the public key, right? But they have Bitcoin on them, and they're called puzzles, right? And anybody who's watching is free to go to these sites. I'm not going to post it because I'm competing with you all, right? So I don't want to show you this, but you can find them online. And my other question to you, Yeti, is, can we use DYNEX's compute? And then obviously I can scale it up with how much compute resources that I want to use to do this sort of cracking. Now, it's not cracking in the sense of like,
it's ethical cracking.
Think. Yeah, it's ethical cracking. And then additionally, it's brute force cracking. So it's not like you're actually cracking Bitcoin and there's some sort of issue with the coin itself. But yeah, just answer that for me.
So you wouldn't be able to do it on DYNEX because that would trigger one of our fingerprints.
Dang it.
That would stop it. However, it would probably see Chris saying I'm listening. Yeah, of course everyone's listening now, right? We talk about nefarious things, everyone listens.
Yeah.
Everyone's once a DGen, always a DGen, right?
Yeah, I mean, that's why I brought it up.
But yeah, I think no, it would obviously trigger a freeze on the job because of what it's doing. Plus, also you'd have to understand how to do that in a quantum environment, right? It's not the same as using some of the code that's already available and just running it brute force one after another. That won't work in a quantum space.
Yeah.
You know, if you were gonna do that, you would widen the scope and work out all the elliptical curve and attack the entire curve all at once. But again, that can't be run on our network. I would love to prove a point and showcase that kind of thing.
Yeah.
But it would be terrifying, right?
Yes.
Like it would be legitimately terrifying. It would scare a lot of people, and it would have probably agencies with 3-letter tags
just knocking on your door.
Right?
I don't.
Do you know what I mean? I'd be getting a tap, tap, tap. Excuse me, sir. Can we have a little chat about something, please?
Yeah.
But then everyone would know the name DYNEX at that point. So
I know
marketing plan.
You know, the old saying, you know, any publicity is good publicity, but that might be a little bit too far. It might be a little bit too far.
I'm just going to assume it's already been done in some other environment.
Well, yeah, of course. But, you know, when it comes to a decentralized ecosystem like this, where the product is essentially already made for you, I just feel like anybody can sort of benefit versus somebody doing it in their own local environment. It makes sense to me. But again, I understand the ethical side, and then also the filtering within that's internal, and that's good that you guys have that. So
yeah, it's one of my, you know, like I come from a cybersecurity background too, right? That's where me and FF probably get on so well and talk because we got that background. But like when I joined, I went super paranoid, like full on paranoia mode.
Yeah, I believe it.
Because, you know, I looked at the software, what you can do in software when you've got that much raw compute available to you. And it's just, well, if somebody misuses this, it's going to be bad.
It's like
not only from an exterior perspective, but from our perspective too, right? Because it damages our reputation, our clientele that are using it. It's a dangerous and slippery path. I just seen a really cool question that you're just about to pull up. I knew you was going to pull that one up. Isn't it time to make DYNEX itself quantum resistant algorithm, or is the existing algorithm used for transactions within the network sufficiently stable? So we're pretty happy with the algorithm at the moment. There are some tweaks coming that will obviously make that a little bit more difficult. The absolute entanglement will certainly make a huge difference, because it's going to change the whole way a blockchain is going to be run. This will be effectively the very first example of an entangled network running in a blockchain environment, I believe, by the time we finish this. It's going to be totally unique. So that's something that we're looking forward to. Quantum resistance, from what perspective? Are we talking from a physical quantum? Because our network's already quantum resistant at that point, right? There's not enough qubits in the world right now to attack any networks. 1100 qubit is not even close to being enough. Now, if we're talking a couple of 100 million qubits, then you could basically do whatever you wanted to. But that's why we have to have that ethics committee. And you know, quantum resistance is, like I say, with ASIC resistance, right? It's only resistant till somebody gives it a go.
Right.
Yeah. Everyone says they're ASIC resistant, and then 3 months later, Bitmain releases an ASIC for them.
Yeah. That's why I think like a certification process through DYNEX would be like amazing.
I mean, that's something that's actually, you know, quite possibly a really cool avenue to research, right?
Yeah, absolutely.
I think FF and I and even yourselves are probably all in the same boat with when we talk about this. That, you know, when you think about a standard, right? Every kind of standard in the world has these set procedures, right? And they test thoroughly. And if you pass, you pass. If you don't, you go back to the table, you get yourself fixed up, and then bam, you're back on track again. So could we do something like that? Absolutely. I'd love to try doing something like that, setting a quantum resistant standard, right? That would be excellent.
Yeah. Where
they can use a service that we've pre-approved and pre-made, right? And then they just ask it where the GitHub is and where the blockchain is and everything like that, and it just goes off and does its thing.
Yeah. Yeah.
And then comes back and says pass or fail. I mean, it would be really cool, and it would be something unique as well, right? Because
it would be, and as an investor, it would be something I'd want to see that the
blockchain securing other blockchains. It's actually an interesting concept. I quite like.
Yeah, yeah.
We should definitely have more of a talk afterwards. So,
absolutely.
I think you guys have the right idea around what we're trying to build at DYNEX, right?
Yeah.
It's about showcasing truly that blockchain is more than just cryptocurrency. Blockchain as a technology is massively powerful and so underrated right now and undervalued as a product. People don't even realize just how much they've got sitting on their table right now.
Yeah, it's also extremely complex for the average person just to comprehend.
Correct.
And I think that's the barrier right there. As soon as like right now, just through our discussion, I've just expanded my mind so much further into what the possibilities are with DYNEX, and I'm hoping our audience gets that as well, because it's very impressive.
Thank you. I mean, we've worked hard, right? We're pretty much from the US all the way over to Hong Kong, right? DYNEX effectively is open 24/7. We don't close, because we've got staff and agents on at all time of the day.
That's
pretty
perfect.
much.
Yeah.
And FF knows I only sleep 4 hours a day, so I mean, I'm always up and about.
Me too, but not intentionally.
Yeah, right.
I want to sleep more. It's just not happening.
Yeah.
Do we have more questions?
I don't think so. And I think
probably we went over an hour and a half.
Yeah.
So a really good conversation.
I would have to
it's been great. It's been great. Thank you for doing that.
I've enjoyed it. Like I've always said, right? I enjoy going down the rabbit hole and interesting concepts and ideas, right? Because what better way to showcase and make people understand around what we're doing than just having a discussion around what can be done, what can't be done, why it should be done, why it shouldn't be done. I think, these kind of talks are immense. If necessary, be able to invent their own patented algorithm that's guaranteed to be resistant to itself. Now that's an awesome question. That is an awesome question. So thank you to that person there and I won't try and say the name because
exactly.
I'm going to absolutely butcher it. So Kep or Sep, either way, thank you very much for the question. It's actually something we're researching now, whether we will effectively patent the idea of this entangled blockchain, but we can't patent what we're already running, right? Because it's fundamentally underpinned by a blockchain technology that we started from. So we can't patent the entirety of it, but we could patent the way that we do the entanglement, right? And that's something that we're working on now. And if we go full entanglement, I would suspect that we probably will IP lock the mechanism, shall we call it, for doing that. We won't be able to patent the actual like hashing algorithm, because fundamentally that's what our blockchain started from. For that, we'd have to hard fork over to a completely new algorithm, and that could cause nightmares, right? We've already got clients now on our network. The last thing we want to do is cause downtime.
Yeah, right.
I think one thing I want to highlight, because I know we're wrapping up, but to his question, if you guys remember IOTA, IOTA created their own custom hashing algorithm. I think it's called Curl, and it had issues with it. So the problem with doing that is if you're doing it internal, right, it doesn't have the same level of Q&A and testing. Even if you go through all of your checks and balances, creating your own hashing algo is extremely difficult. So I just want, if you are looking into doing that, Yeti and as a DYNEX team, just be wary, look at past mistakes from other teams that have done it.
Like we'll look at what we can do around the entanglement side of things. I don't think we're going to change our entire hashing algorithm, mainly because at the moment it's working as expected, and there's always room for improvements. Plus, we also run some very unique tool sets on our blockchain that aren't available on other blockchains. Because of obviously the PoUW mechanism, we actually control who can and who can't mine on our network effectively. It's how we can keep ASICs off our network.
Yeah, okay.
So we can just ban the IDs of what an ASIC would join on. Now, they could spoof a certain miner, but at the end of the day, we can just ask our miners to update, and then they're blocked off again immediately. So...
Gotcha.
But no, thank you for this talk. It's been wonderful, guys. Really, I've enjoyed this immensely.
Great talk.
Again, I'm going to be watching everybody in the chat.
It's been super impressive. I love the questions. I always love answering the questions. Because the more we explain, the more people understand. So that's why I never have problems answering questions, because even the tough ones, right? Because the tough ones are the ones from people that are genuinely interested. That's how I look at it. So
I
hope we didn't get in too much trouble.
Oh, don't worry. The boss is used to me dropping me, the staff right in it.
Here and there.
Oh, believe you me, I'm sure he'll send me a message shortly after. He'll be like, "I told you not to say anything about that." I'll be like, "Oh." Getting myself in trouble, but no, I don't mind doing it, because the more we show off, the more people can understand.
They understand what you're offering. Absolutely.
Even like work in progress stuff that we've shown off, like the quantum NLP for a bot talking to you, right? We haven't released the code for that yet because it's not quite ready, but we wanted to showcase what it's doing because we're really, really happy and impressed by it. So of course we wanted to showcase a little bit of it, and then from there it'll come out, and then people can start building on top of it.
Amazing.
Thank you
thank you for your time. Hour and a half, great conversation. I'm hoping we have you again on this.
I did warn you that it's going to be a long one if we went down the rabbit hole.
I'm going to have a huge list for the next conversation, because you just opened up a realm of possibilities over here.
Nice.
So thanks again for joining us on the
No worries at all.
All right. Cheers. Thank you, everyone. Thank you for joining. Have a great Tuesday, and we'll see you next week.
Take care.
Bye-bye.